FDP. Today's topic is GAN and its advancements with quantum computing by Dr. Girish HR. Dr. Girish HR is currently working as a technical architect at Xavier Bengaluru. He received his BE from SIT Tumkuru and MTech from Siddhartha Institute of Technology and completed his PhD in biomedical image processing from VTU Belagavi. He has 10 years of experience in the IT industry, especially in big data and related technologies. He worked for 2 years as a project team lead at Lini Top Network in the R&D team China. He spent 4 years as a lead software engineer at Intelligent Engineering Services Private Limited and 2 years as a technical analyst at Coforge. He received Exceptional Performance Award in 2019 from his company for his excellent work and contribution to the project. He has more than 20 paper publications in journals. Currently, he is working on a big data project. Welcome you, sir. We are happy to have you here. And it's over to you, sir.
Thank you, Shweta madam, for nice introduction. Thank you so much. Hi, good evening all. I hope so everyone doing good. I think so. No one is turned on their video. I don't know, but yes. So as Shweta madam told that myself Girish, and then I started my career in 2016, and then I worked in China almost 2.5 years, and then I came back to India, and then I worked for the client, the Western Digital. You guys know already that the manufacturer, that is the organization, the SanDisk pen drive, and then the WDC, that hard drive and all, right? So those are the products of that organization. Then after that, I worked for the client, the travel domain Emirates, so that airline domain. Then currently I'm working for the Xavier for the project IQVIA. So this is the healthcare domain. So my daily task is like that. As a developer, big data developer, we need to do the data processing and then data cleaning, and then we must have to give the proper output as per the client requirement. So, and then we are digging to that the machine learning, artificial intelligence also, because of what I am dealing. This project is mainly the artificial intelligence and machine learning project only. So, and then thank you so much for this giving this opportunity. So, and then now I'm going to start the presentation. What is the topic we are going to cover it by today? So here I'm going to share my screen. Okay. Yeah, you guys, I think so you're able to see my screen. If you are able to see, you're able to see visible, yes, madam. Yeah. So today I'm going to talk about the generative adversarial networks and then its advancement with the computing, the quantum computing. And then here I'm going to tell about the information about this the GAN. But before that, whatever the things we are going to deal, that data is very important. So without data, we could not do anything. So that is the reason I am telling you how we are going to deal with the data. And then if you want to do any research and all, whatever the platforms are available in the market, and then with the free edition. So, and then in real time also, what is the framework we are using. And then here I'm going to show you as an hands-on session. So the simple examples, the drop the duplicate data, and then the SCD, the slowly changing dimension type 1 and all. So these are the simple example here I'm going to explain you. So before that, I'm going to cover this generative adversarial networks only. So as Shweta told us, and then I'm currently I'm serving as a technical architect in Xavier. So then, yeah. So before we must know what is the GANs and all, right? So before we are going to tell about anything, the origin and then what it is and all, this is very important. Before we are going to cover about how and why. So this is what the GANs means. This is the generative adversarial networks. So initially it is introduced by and then Goodfellow and then other researcher from the University of the Montreal in 2014. Okay, so and then so it is mainly related to this neural network. It is also one of the set of the generative AI also, generative artificial intelligence. We know already the generative artificial intelligence nowadays it is booming the market, and then every organization they are using this generative artificial intelligence also, and then they trained us on monthly basis, and then weekly basis, and all the technologies and all, because the nowadays that all the organizations what we are working, that IT sectors, they are not going to search it outside the resources, they are training inside, or those are working inside of the organization now. So that is the reason they are training us. So, and then many the courses also available were in the internet. So, and then what it is this the GAN in the sense, so it is going to generate the new content that has never been generated before it. So that is the new the content or else new data it is going to generate it. So that we can call it as in the GAN. So mainly we know that the machine learning and then in artificial intelligence there are two types of the things. That is a supervised learning. We know that supervised learning means that is the labeled data, and then another one is the unsupervised learning. And then we know that the unsupervised learning is this is the unlabeled data. So the labeled data in the sense the what is the input, and then we can expect the expected output and all. We can train according to that, right? But as coming to this unsupervised learning, so yes, we are going to train the input, but we doesn't know what is the output is going to generate it. So like that, we can call it as in this unsupervised learning. So this GAN also belongs to this unsupervised learning only. It is not in supervised learning. So, and then where we are going to use this, the GAN technology. So especially we are going to use this technology in images, that is what image processing and all, and then music, and then speech, that is what the speech recognition. So, and then removing of the noise. So, and then images in the sense that image classification, and then image identification, and then music also. We are going to compare the original music with the duplicate or else fake music and all. And then by writing also, that is what writing in the sense we know that ChatGPT already we knows, right? So when we are going to type it, just if you type it the Spark, so it is going to generate all the related information belongs to the Spark. So instead of that, it is going to search Wikipedia, it is going to wherever the data is available in the internet, it will fetch in fraction of seconds, and it will generate the if you want to the output as an image format also, it is going to generate in image format, or else if it is in text format also, it is going to generate in text format. So like that, we can use this technology in different domains. What I'm going to tell you, before we are going to use any the machine learning or else any artificial intelligence algorithms or else any technologies, the data is very, very, very important. So without data, we could not do anything. So the data in the sense, it is an information. It may be the different kind of data. So it may be a structured data, semi-structured data, and then the unstructured data. The structured data in the sense, that is the tabular format of the data. So already the rows and columns are defined. But the semi-structured data in the sense that email, so the and then XML data. So these are the data belongs to the semi-structured data. And then unstructured data in the sense we know that already that video, the music, the different kind of that videos and all. These all the data belongs to this the unstructured data. So especially nowadays the very difficult to deal the unstructured data. So because of all the sensors, all the robotics, this all the information we are going to store it in unstructured data only. So that is what this is the big challenge for us to deal with the unstructured data. But as coming to this, the structured and the semi-structured data, we are not going to face any the issues, or else we are not going to face any challenges and all. So like that, so these are the very important. We must know about of that the data information also. We must know about of that the nature of the data, and then how it is going to generate, and then per hour or else per minute or else per day or else per month or per year. So like this, and then the data privacy and then security is also very important before we are going to train up any the generative AI models and all. So this is what the basic information about of the data and all. So, and then what I am working in big data. So we must know about of this already big data. That is a large amount of the data. So let's take an example before 10 years and all, or else before 10 or 15 years, we are not using any mobile phones, or we don't have any that much of that information sectors and all, right? So, but nowadays everyone they are having the mobile phones, everyone they are using the digital TVs, everyone they are having the different what I'm going to say, the technology assets and all, right? So on daily basis, on every second, the data is generating and all. So in this way, we are going to deal the data, and then once we fetch this data, and then we are going to feed up to these models and all to the generative adversarial networks and all. So especially in these GANs, it is mainly consisting of the two main components. This is the architecture. This architecture mainly consisting the two components. The first component is generator, and then the second component we can call it as an discriminator. So
Giri sir, like the slides are not moving. We are just in one slide only, first slide.
yeah, I'm going to, madam. I'm going to move.
Okay, okay, sir. Okay.
Yeah. So there are two components of that the GANs. That is what the generator and then discriminator. Maybe in the next slides, I'm going to explain what is the generator and then what is discriminator. But before that, I'm going to tell you about the evolution of this the generative adversarial networks. So it is the major breakthrough in the deep learning and then artificial neural networks domain. So because of it is very fantastic technology. So predict or else to find out the different images or else to label the different images in the group of the different animals or else different the voices and all. So just it is started as in one simple one publication. How we are going to publish our the research work and all, right? As a PhD holders, when we are doing research and all. So what are the works we are doing? Just we are going to publish through the paper. So this technology also, it is first it is started as in one simple publication. Then after that it became very popular as compared to the other technologies. So see what is the main the before this, whatever the technologies they are used it, they are not getting the absolute result or else the satisfied results or else the expected results. But once this the publications also or else once this technology came into the market or else into the world in 2014, it is booming like anything. So and then it is going to give us the satisfied results and all. So and then this is what the GAN, the first technology. This is the producing that high quality result on the most of the data sets they were trained on. So as I told that the data information and then data quality and then these are all the right. So once they are going to feed the data into the GAN and then they got it the good results, that is what high quality results and all. So then from that day onwards, it is going to booming in the market. So this is the evolution of the GAN. Yeah. Before I'm going to we know about of this GAN, we must know about of this convolutional neural network. I think so. We know already the what is a convolutional the neural networks and all. This is also belongs to this convolutional neural network only. And then what is this convolutional neural network? And then see we know that this convolution these CNNs are trying to classify the different images, right? So with respect to the labels, let's take an example in the group of images, the cat image is there, and then dog image is there, and then elephant image is there. So like that, the different images are there. In that images, we are going to find out it is a cat image or else we are going to particularly dig into that image, and then if you want to find out only cat image or else if you want to find out only the elephant image or else if you want to find out any particular dog images and all, how it is going to analyze this? It is going to analyze that in that images the bunch of images by pixel. So pixel, we know that every images it is mainly consisting the pixels, right? The multiple of pixels are, that is what pixels into belongs to the images only, right? So it is going to first analyze this pixel in that images, and then it is going to pass through that every nodes in that the CNN in that hidden layers, and then finally it is going to tell about that what is the image. It may be a cat or else it may be a dog or else it may be an elephant, like that. So that is what we can call it as in this convolutional neural network. So that is what here I written that the example, simple example only. The CNN is try to classify that the dogs and cats and then images. So this is what we are going to fit this into this CNN. So this is the one simple example of this convolutional neural network. And then this is the brief information about this convolutional neural network. Why I am telling this convolutional neural network? Because this GAN belongs to this convolutional neural network only. Based on this only it is going to work. So without knowing about of this convolutional neural network, and then we are not going to understand anything about this GANs and all. Okay. So yeah. As I told in beginning, so mainly this GAN consisting of that the two components, this architecture. That is what one is generator. The second one is the discriminator. I think so. The name itself it indicates that generator and then discriminator. Generally, generator in the sense what it is going to generate something, right? The discriminator in the sense what it is going to differentiate between the two different things or else the many different things. That is what we can call it as the discriminator. So from this slide or else from this picture, we came to know that this generator, in the sense, it is going to generate a new instance of the data. That whatever the data is going to generate it is not existing before. You understand, right? It is not existing on before. That we can call it as a generator. Maybe in next slides, I'm going to explain in deep of this generator. The next second, the part of the GAN, the discriminator. So the discriminator, in the sense, what, how we are going to discriminate any what is that, anything, in the sense we are going to differentiate, we are going to compare two things. It may be 0 or else 1. So 0 in the sense it is false, 1 in the sense it is true. So like this discriminator, it evaluates the authenticity of the generated image. So once the generator, it is going to generate the image, and then it is supplied to the discriminator, or else it is feed to the discriminator. Once the data or else the images from the generator, the real images and then fake image, then discriminator, it is going to discriminate it, or else it is going to differentiate between these two images. It may be a false or else true. So if the generated image from the generator, it is maybe next slides I'm going to explain. Okay, so this is the the definition of the generator and then the discriminator. Yeah, so as I told, this generator mainly considers the random values in the sense including noise also, and then there is no fixed values because it is continuously going to considers the random values only to generate the images. So there is no fixed values for this. So once the images is generated by this from this generator, then the discriminator along with the stream of images taken from the real data set. In the sense, what I'm going to tell you, the already the generator having the database, and then already that model having the trained having the database, that is what real image already they stored in the database, and then in the discriminator also having the database. So that database also having the multiple of the images and all. So in this, the generator, whatever the already the data or else images are available from the database, it is going to whatever the images or else data it is generated from the generator, the both the images is more or else is fed into the discriminator. Then this discriminator, it is going to already it is having some amount of the images, or it is already in this database some amount of the images. It is going to make the differences between these two images, whatever the images generated from the generator, and then whatever the images having the discriminator. So the discriminator returns the probability of the generated image. It's being real or else fake, like that. So that is what I'm telling. Whatever the things you can take it, it may be true or else false. This discriminator, it is going to consider this real image as an 1, and then it is going to generate if it is the image is in false in the sense, or else it is a fake image in the sense, it is going to 0. Only 0 or 1, that's it. Okay, this is the generator and then discriminator is going to work. Yeah. So this is the way of the generator and then discriminator. So already I told that this is the training data set. Already we are having the database. In this database, already we have stored the whatever the images we are going to compare between these two, the images generated from this generator. So and then this both the images are passed to this discriminator. So this discriminator, it is going to compare this training set in the sense this is the real image, and then this is the fake image. So this fake image, it is not in one image, or else it is not in one time image. Multiple time it is going to generate it until and then this discriminator generates the true or else false results. It is continuously, it is a continuous process until and then get the real or else fake results. So like this is the GAN it is going to work. Okay, yeah. So how these GANs work? So this discriminator is in the standard convolutional network. We know that what is a standard convolutional network? It is in binary classifier. So it is in that labels the images are real or else it's in false. We know that, right? But as coming to this, the generator, this generator, it is not in standard convolutional classifier. This generator is this an opposite. So what it is, and then this generator is in the probability. So this is it is going to find out the based on the probability. So while the standard convolution classifiers, So it takes images from and then down sample to the return to the probability. So then this generator takes the random noise vector as I explained from the previous figure, and then it is unsamples into the generating image. So that should be analyzed by this discriminator. That is what we can call it. This generator and then discriminator are opposite. These two are not in same nature. Both are in different natures. Okay. So what we are going to means this discriminator and then this generator, this both are trying to optimize the different and then opposite fitness function. That is what we can call it as a loss function. We know this loss function and all. And then during this training, so the generator and the discriminator, absolutely I told that these two are going to change their behavior. It is not in same or else it is not in constant behavior. Both are in, yes, it is going to change the behavior. Maybe next slide I am going to explain it. Okay. Yeah. So then they will be against the other. Because of this, it is going to losses, as I told that 0 or 1 from the discriminator like that. So and then next what we are going to tell, these two are computators. It may be a discriminator or it may be a generator like that. Okay. So this picture only, it represents that. So generator network and then discriminator network. So the generator network is opposite of this discriminator network, and then this discriminator network is opposite of this generator network. So how we are going to try this discriminator and then? So this discriminator network is trying to distinguish between the real and then generated data. The real in the sense, as I told that the generator having the real images database, from there also the images is generated to the discriminator, and then from the generator it is going to generate the fake images, or not fake images. Yeah, we can call it as in fake images only, the different images. So in this way, this discriminator, once it is getting it from the generator, then it is going to use this loss function. So it measured to, so what is the use of this loss function? This loss function is going to use to measure the difference between the new data, the real data and then fake data from the generator. So that is what in that way we are going to train this the discriminator. So from this picture only you came to know that what is real and then fake, and then discriminator. So the discriminator is going to discriminate between this real and then fake images. It is very big task for them. Okay. So these are the main simple example of this the training the generator network. These are the real data from the noise that is the generator is going to generate it. So this is what the simple example, the training the generator. So this is the original image, already we stored it in the database at the generator side, and then this is the images generated from the GAN generated image. See here, what are this image and this image is some having a difference, right? So like this, the generator is going to generate the images along with the noise and all continuously until and then the discriminator identify it is a fake or else real image. See how GANs is working. It is a full discriminator, and sometimes the discriminator also it is going to fool it. Because of that, it's very difficult to find out that it is real or else fake images and all. So this all the implementations or this all the work or else it is all the things is going to happen in the fraction of seconds or else fraction of minutes also. Maybe not fraction of minutes, only a fraction of seconds only. Already we experienced from the ChatGPT. The best example for this GAN technology is the ChatGPT. I think so. You guys already know about this ChatGPT. Yeah. So as I told, how this the GANs working and all, right? So first, initially, the first attempt. Let's take an example. The discriminator want to find out the difference between the whatever the images generated from the generator and then from the fake images and the real images from the generator. The generator having the cat image that is from the real database or else real images, and then it is going to generate the fake images similar to the cat based on that labeled data, right? As I told that unlabeled data. So initially this generator, it is going to generate, this is the first image. Okay. Next again, it is going to send it into the discriminator along with this the cat original image. Then discriminator easily it is find out that this is the fake image or else it is in false. Then it is going to send this information again to the generator. Again, this generator, it is going to generate another image along with that noise and all. So the next it is going to send this to the discriminator. Then discriminator easily came to know that, yeah, this is not an original image, but even the fake image. Again, it is a next process. Until and then it is going to get that the original image. Again, it is going to the generator, it is going to generate the original image from as in third image. And then discriminator easily find out that, yeah, it is the true image or else true information. Then it is going to using this last function to find out this original image. Okay, so like this the generative adversarial networks, it is going to work. Then these are the different types of GANs. So some examples, if you want to note down this. So deep convolution, and then the WGNS, and then super resolution, then image to image, cycle generative, then stacked the GN, and then progressive growing, style based, vector quantized. So these are the main different types of that GANs. And other lesser known about this very interesting. These are the some extension of this SGN also, information GAN also. So like this, these are the different GANs and all. According to our requirement, we are going to use the particular type of these GANs in our technologies, or else in our real-time experiences or in real-time projects. So these are the main the GANs applications where we are going to use. This is the simple example of that the paired image to image translation. Let's take an example. This is the input image, right? So this is the input image in the sense this is the labeled street scene only. So here output means this the discriminator, if it is until and then get this the street scene and all. So until and then it is this generator, it is going to generate this input to this the discriminator. Then it is going to send this information to the generator. So this is the labels to the facade, and then this is the between two color also. So this is a shaded color, and then this is the different colors and all. This is the input, as we need to find out that the particular the location from the particular area and all. So these are also very important, day to night and all. These are the edges to photo, the how to find out that particular bag and all. So these are the simple example or simple applications of these GANs. So and then where we are another application of this GAN also, it's in that unsampling of that the as I told that we can expect that good resolution of the images also. See, these are the good amount of good resolution of the images from this GAN technology. So instead of this the low resolution images, so like this in different application part we can use this. And then as I told that the text to image generation also, as I told the ChatGPT is the best example. If you are going to type it any word in text format, it is going to generate it in the image format, right? So that is also there also we can use this the GAN technology. They use this GAN technology. And then see, based on that, once you are pass the images into that the GAN model, then it is going to easily find out that the age based on their the label, based on the eye, based on that the face recognition and all. Because before already we trying that model. So what are the things it is going to consider to find out that the particular age for the particular person and all. So in that applications also we can use this GAN technology. So and then we can use the GAN technology to generate the faces of the people does not exist also. So let's take an example. In these images, this guy is not there, right? So like this, before that the images that is or the person is does not exist, those kind of the images are it's going to generate by using this the GAN technology also. So and then we are going to use this GAN technology to fill the missing part of the images also. So missing part in the sense we know that already somewhere to find out the investigation or somewhere to predict that. So we need some clarification of the images and the particular information of the images. But in that images, the few information is not available. But based on that, whatever the data we are feeding into that GAN technology, already we trained into that, it is going to predict that whatever that exact images for the missing parts and all. So in that part also we are going to use this GAN technology. So and then the generating of that images of the new human poses also. So from this picture only you'll come to know that. So like this in different areas or else in different applications we are using this GAN technology. And then restoration of these old images and then noise removal also. Maybe this is also very important. So this is one of the challenging part in the GAN technology. So here in this area and all we are going to use these GAN applications and all. So finally, conclusion, this is the continuous advancement in GAN technology. It is not fixed or else it is not already decided. It is continuous process. It is a continuous advancement in GAN technology. You can do your research also in this technology. As coming to this research, as I explained you, these are the different applications and all, right? you can consider the different applications, and then you can apply this GAN technology in your own applications, and then you can do your research also, and then you can do your improvements also. So, and then where we are going to integrate this GAN technology, absolutely we are going to integrate this GAN technology into the different fields and industries. In our real-time project, for that ETL tool and all, we are using this Spark and all, right? So instead of that Spark and all, we are going to use this GAN technology also to extract, transform, and then load the data in our real-time projects. So like this, we are going to use or else integrate this GAN technology. So this is the main, the basic information of that GAN technology, and then different components of that architecture, the components of the architecture, the generator and then discriminator, and then whatever the different applications, and then what kind of it is GAN. It is an unsupervised learning, and then it is belongs to this the CNN model also. So this is the main information of the GAN technology. Okay. 1 minute. Yeah. If you guys, if you have any doubts, let me ask about any what I explained now, or else I'm going to show you some hands-on session to you guys. If anybody having any doubts, please raise your hand.
Hello. Hello.
Yes, sir.
Yes,
Sunil,
sir. Sir, I have one doubt. Can we use GN in signal processing? Because till now I have seen some image processing only. So can you use in signal processing?
Absolutely, we can use it, sir. The signal processing is an information. It is noise and all, right?
Yes, sir.
We can use it. No worries. We can use it.
And secondary, sir, we are generating a synthetic signal, or we can say data, and one we have real data. So before going for discriminator, we are training, then sampling, and then sending in discriminator, both real data as well as in synthetic data.
Synthetic data, yes.
I promise that, sir. Suppose we are comparing discriminant based on the loss function. That is the average probability we are calculating, means expected average expectation value we are calculating. So here, how we are detecting means detecting the whether real value we are predicting or fake value based on the probability or some other values.
See, based on the probability value only, and then based on the probability value only, it is going to differentiate the fake images and then real image.
Okay, sir. So we have one formula, sir. Log of 1 minus d of discriminator value and log of generated value. Like that, we have 1 minus generator of that data. So
absolutely
in that, we are inverting. So we are getting the 180-degree phase, means we are the point getting maximum loss between the generator and discriminator with negative sign. That we are going to tell that is the getting the maximum loss function in the generator and discriminator. Based on that, we are detecting. But problem, how we are predicting this one is, sir, because you know that we have some tools we can use, but I want to do modeling. In that case, I'm facing the issue by doing the modeling of that part.
You want to do modeling and all, we can have this as like the generator having that the database, right? The database having the real-time images and all, right?
Yes,
so like that, we are before that discriminator also, we are going to try and up with the different images, or else whatever the relevant images, real images too, we are going to insert into that the discriminator part also. So from that in that context, we easily it is going to differentiate it is in real time or else fake image.
Okay,
hello
sir. Yes.
You understand, right?
This part clear, sir.
Yeah.
But how we are training this data, sir? Suppose you want to train this data, how we are, because it's both are pre-trained data, then we are sending the discriminator. Again, 2 point I'm facing difficulty. One's pre-trained data, and then the calculating. Now just you tell like that. So now that point is clear. And now this point, how we are training, pre-trained, because both data we are training before sending in discriminator. Real data also we are training, and discriminate generated data also training. Both are training, and then we are sending. So this point I'm getting how we can train this one, sir, by using any like neural network method or some means any machine learning method, or direct we can
Absolutely,
like
we are going to use this neural network only.
Okay, sir.
Yes. This is mainly what I explained. This GAN and all, it belongs to neural network only. Absolutely, we are going to use this neural network only.
Yes, sir. Thank you, sir.
Welcome. Super, sir. Nice. Okay. Now I'm going to show you the hands-on. Okay, for you guys. See, in our real-time project also we are using the same only. The Databricks. What I'm going to explain you guys. So this Databricks, the production level, the Databricks is also there, and then the free edition is also there, and then licensed the Databricks edition is also there. In current project, most of the organization, I think so, almost 60 to 70% organization we are using this Databricks only. So the Databricks platform only. Why means this Databricks in one platform? We can get it all the things. It is in ETL, data processing, and then the job scheduling also. And when coming to this on-premises and all, we know that, right? That on-premises, what is the difference between this on-premises and then cloud technology? In one under umbrella, we can get it the different the facilities and all. But when it's coming to this on-premises, this on-premises having the old technology, and then for every task and all, we must have to depend on the different technologies. Let's take an example. As a developer, if I want to do any the data processing, or else if you want to do any implementation of any applications and all, in on-premises, to write the code, I have to use in my current project and all, IntelliJ, that should be installed in our laptop or else in the cloud, or else, and then we must have to use this IntelliJ, Eclipse and all to write the code. But when it's coming to this Databricks, already it is predefined, and then already they made it for us to write the code and all. It is very easy to write the code and all. And then next we are, if you want to going to schedule any jobs and all in on-premises ETL and all, you must have to use the separate tool for that Scoop or else the Informatica. These are the different technologies. But when it's coming to this cloud and all, already they are having these ETL tools, whereas in the different cloud providers, it may be AWS, it may be a Azure, or else it may be a Databricks and all. And then for the job scheduling and all, in on-premises, we must have to depend on to create the jar files and all, that Ansible, Jenkins and all. But as coming to this cloud platform, no need to depend on this Ansible and then Jenkins and all. Already they are having their own the platform and all. So therefore, it is very easy task and all. But as a developer, or else if as a machine learning or else artificial intelligence, we must know about the different algorithms and then different logics, and then as per the business requirement, so you must have to write the code, or else we need to give the solution to the client or else to the customer. So like this here, I'm going to show you the simple. Okay, you guys also, you can try it in your hand if you want. Just a minute, I'm going to share my screen. Okay, yeah, you guys are able to see my screen, right? You guys are able to see my screen, right?
Yes, sir.
Yes or no? Okay.
Yes, sir. Yes, sir.
Yeah, if you want to do any research, or else if you want to do any the practice to understand the big data technology, or else if you want to understand this machine learning, or else artificial intelligence and all, or else if you want to explore the different data set, or else if you want to do any some experiment and all, you can easily use this Databricks Community Edition. So everyone, they write down your the framework, but I'm going to explain you. So already see here the Databricks Community Edition for free is there, right? So just you click on here, and then if you are not a user of this Databricks Community Edition, some basic steps are there. So that you're supposed to give this email ID, and then you're supposed to create the password, and then it is going to ask your credit card. So credit card only, it is going to credit only ₹2, and then after that also they are going to refund it to you. So and then once you create this, because to create the account itself, it is going to take the time. So that is the reason here I'm not going to explain how to create the Databricks Community Edition, or else a free version. Okay, already I have the account, the Databricks account, the free edition. So here I'm going to explain how it looks, and then how we are going to utilize this. Okay, so this is the way to create the Databricks account. See here, this is the Databricks. Okay, 1 minute. So this is the workspace. In this workspace, whatever the things you are going to create it, the folders or the different applications and all, every information it is having here, or else here I'm going to show you. Yeah, so here, okay. So workspace in the sense, yeah. So this is who is the user is going to share it. I mean, so going to use this and all the information. My username is already girishsc@gmail.com. It is there. Okay. So then here this catalog. So this is the one of the beautiful the addition or else beautiful the technology or else important future. Yeah, important future they added by this Databricks the organization or else the Databricks company. What is this catalog use in the sense? This catalog in the sense, let's take an example. We're having multiple kind of the databases and then multiple databases having the different kind of the tables information, right? So before we're going to use these databases and all, we can merge this all the databases and then different tables into one catalog. One catalog, how we are going to differentiate catalog in the sense, let's take an example as a developer one catalog. So they can use this one catalog. They are also getting the same data. As a tester, they are having the different catalog. So that in that catalog, the tester also they can use that. And then as a production environment users, that production environment users also having the different catalog. So from this, all the three different catalogs, so they are going to differentiate as per the roles and responsibilities, and then as per the data requirements and all. So like this catalog is going to use it. Then these jobs and then pipelines. See, any application, let's take an example. Once I created any applications, I want to run that application on daily basis. See, if I started by today at 6:41, so it's supposed to be continuously this job is going to execute until and then 3 months, 1 year, or else 1 day, 2 days, like that. For that, we are going to use the job and pipelines options. So this is the job pipelines having the different options here. This is the ingestion pipeline. This is the ETL pipeline, and then this is the job. As I told that we are going to use the Woozy and then Airflow wherein on premises. But this Databricks having this own job scheduler, we can call it as a job scheduler. So this ingestion of the pipeline in the sense, this is the ingest the data from that POP. In the sense, let's take an example. I will take my real-time example only. That Western Digital having the product of the SanDisk pen drive and then different hard drive and all, right? So that is hard disk and all. So they're having manufacturer the factory RLs. In that manufacturer factory, so the initially the data different to 22 layers. So let's take an example. One pen drive in this sense, they're having the 22 layers of the 22 layers. So before they are going to generate or before they are going to produce into the market, that all the 22 layers information they are going to store it in text format in their own system in that factory outlet and all. That information we want to get it into our environment. Because of that, to do the next further information. So that is the reason we are using this ingestion pipeline. The next ETL pipeline. So in this ETL pipeline, this is what extract. That is what, as I told, that extract the information. Then transform. Transform in the sense, if the basic information or a source information is the text information. If I want to convert into the CSV format in the sense, that is what we are going to transform from one form into another form. Then load in the sense, we are going to load that after the transformation into the target location. It may be Azure Blob Storage. It may be AWS S3 also. It's all depend on that the cost, and then it's all depend on the environment. So on this ETL pipeline, in this Databricks, we can use this SQL also, the structured query language, if you want to do any transformations and all. And then we can use this Python also to do the transformations and all. Then as I told, this job, this is the job in the sense all-purpose job is there, and then clustered job is there. All-purpose job in the sense this is continuously, and this is the less cost effective. And then the clustered, the based job in the sense only the particular application. If I want to run that job in 1 day, that's it. After that, it is not going to execute anything. For that reasons, we are going to use this the clustered based job also. Because of this clustered job is very cost effective. It's very too expensive. And then the all-purpose cluster is the very less expensive as compared to this clustered job schedulers. So like this, we are going to use it. Then compute. As we know that why we are using this compute and all, the compute in the sense, what are the servers we are using, the serverless, and then how many the driver nodes it is allocated, and then how many executors nodes it is allocated. So this all the information it belongs to this the compute. Then SQL editor. Here itself, here we are not going to depend on any MySQL or else PostgreSQL or else any Oracle and all. It is having own SQL editor from this Databricks. So once you imported the data for this workspace and all, easily we can write the queries and all, and then easily we can write we can expect the expected output and all. Okay. And then here also, this is the queries, whatever the queries information and all history, it is going to generate, it is going to save it here. So Gen AI also, nowadays we are using Gen AI and all, right? So here also it's beautiful, the future it is added here. Like this, the many opportunity means many the different things are there. This is what here we are going to segregate into this Databricks. They are segregated into two different areas. There is one is the data engineer. So and then second one is the artificial intelligence and machine learning. So if you want to do any work based on this artificial intelligence machine learning, you can use this all the features from this Databricks. If you want to do any data engineering tasks and all, you can use this to the job runs and the data ingestion, the features in this Databricks. I think so you guys understand, right? This is the basic information of this, the Databricks. You can also try it from your end. Okay. So here I'm going to explain one simple example, how we are going to use this Databricks in our real production environment and all. Okay. Yeah. See here, this is that one Databricks having the notebook. If you want to write any code and all, we must know, or else we need PyCharm, IDE, or else IntelliJ, or else Eclipse and all, right? We must have to install that it's very hectic and all. So here no need to worry about this all the things, because everything is available in this Databricks cloud only. So then here how we are going to create this notebook. Here just you are going to create this notebook. Then if you want to upload any data and all, you can upload the data also, the data set from the internet or else from the downloaded space also. Here already I created the notebook here. That is what here I named it as a dropping rows. So what is this dropping rows? Here the multiple the duplicate the days are there. Here I'm going to drop the duplicate days here. So before that, how we are going to see, the Databricks is mainly working on the cluster formation. So here already it is there. So you need to create the new resource for this. So just to click on this new resource, and then here the many options are there. Whatever the by default option it is coming, just leave it like that. So here the different versions, the whatever the versions of this Spark, Scala and all, it's available. It is already naming here, because suddenly we are not going to change the versions and all, and suddenly on daily basis or monthly basis. Once the project is started, if we used that the Spark as in 3.5.2 and then Scala the 2.13 version, it says we must have to carry out complete the same version throughout the project only. So suddenly we could not. If you want to do any changes and all versions and all, that we can call it as a migration project, because that the supported files we required, and then the many things are there. That is the reason. So we're not going to take it easily. So once we use it the one version, we are going to follow throughout the project. Okay. So already nowadays in the market it's available, the Scala 2.13 and the Spark 4.0.0. The Spark, whatever the technology what I'm explaining now. So this is the 100 times faster than this Hadoop technology. And then here we are going to deal with this real-time data also by using this Spark streaming. As compared to this Hadoop, Hadoop only we are going to deal with only the batch processing data. But Hadoop is the map reducing, but the Spark is the in-memory processing. And then in Hadoop, only we are going to use Java, but in Spark we are going to. Hello, you guys are there?
Yes, sir, we can hear you.
Okay. So like this, we are stick on to one version only. So here the Databricks having the different cells having the one notebook only. So here it is the file is there, edit version is there, view is there, run and all. Okay, here I just simple one example how we are going to execute this. Okay, here I'm going to write the Spark. Okay, once you type the Spark, it is going to give the information about of the Spark versions and all. Okay, what are the Spark versions and all. In the same notebook, if you want to change the languages, you can change it here. Here I am going to execute this by using the Scala language. If you want to switch into the Python, just you simply click on this Python, and then here it's going to ask this your permission. Then click on that confirm. Sorry, madam. Yes, someone is talking. Please mute yourself. Yeah. So then how we are going to execute this? See here there is option here. The run cell is also there. And then if you want to run this complete notebook, just you select on this run all above. Or else if you want to run below also, like this, the many options are there. Or else you can run this cell by using shift and then enter. See, it is going to execute in within fraction of second. See here, it is executed here. Right? So here I'm going to show you the simple example. Here I'm going to create the data frame. Data frame having the two column. That one is the ID and the second one is the day column. Okay. The ID in the sense the ID column having the numbers, the 1 to 4, and the day column having the different days. So here, if you want to generate your own data, so this is the way to generate, or else it is going to give the output as for how we are going to feed the data. So here, val schema is equal to list of 1, Monday. So this is the list. In this list, I'm going to pass the different days with the different values. See here, Monday, Tuesday, Wednesday, Thursday. Again, Monday it is repeating, and then again Tuesday is there because Monday and then Tuesday is repeating. Therefore, these are the duplicate records. So these values we are going to convert into the data frame. Okay. So once we are converted into the data frame, the data looks like this: the ID and then day. This is the structured data. As I told that the structured data having the tabular format. That is the columnar values, that is tabular format, means column and then row values, right? So like this, these are the different values. See here, by default, it is going to give the data type also. No need to worry about this data type. Or else if you want to change the data type as per your requirement, we can change the data type by casting the values, or else by casting the column. Okay. So here initially it is taking this ID as an integer and then day as a string. So here I am going to use only one line the code to drop the duplicates. But as compared to this Java and all other technologies and other coding languages, it's very hectic to handle this kind of the simple examples also. But in this Spark and then in artificial intelligence and the machine learning, it is very easy. Just I'm using, this is the inbuilt function, that is what drop duplicates. So this is what the val duplicates. This is the one another what is that the variable, that is where you can call it as a duplicates. This is the schema before that where we are loaded the data, and then this drop duplicates is the input function. By using this and then list of day, this list of day in the sense this is the day only, right? In this day we are going to remove the duplicate values. This is the show. This is the show in the sense the final output, and then it is going to generate the output like this. See here, ID Monday, Tuesday, Wednesday, Thursday. So no need to worry about it. Just only we are using this drop duplicates. This is the input function, and it is going to generate whatever the desired output if you want it. So this is the way. And then another one example here, coming to example, show you that SD type 1. This SD type 1, this is what the slowly changing dimension. You guys know or what, I don't know, the slowly changing dimension in the sense it is going to replace that historical data, and then it is going to overwrite the new data. But we did not get that historical data information. Once it is got lost, means lost only. This is what SD type 1. That SD type 2 is also there. That SD slowly changing dimension type 2 is, it's kind of that it is going to maintain the historical data also as along with the new changing the data also. So here I'm going to show you that SD type 1 example. So this is the SD type 1. So we need to import this the particular libraries and the particular the relevant that inbuilt functions and all, right? So this is the way to create the different the schema and all. Already I created here. So see here, just to single click, that's it. See here, I am going to create this data already because this already I created this. So the next is here I'm going to create another one also. See, this is what one data set. Okay, this is one data set, and then this is the second data set. In the second data set also, it is having the information like this in tabular format. This is also structured data. This is also structured data. See here. Okay. So, and then here I'm going to using this SSD type 1 to overwrite that the historical data with the new coming data. Okay, see here it is showing both the values here. See here, the old data is not available, only the new data, whatever the data we passed or else we are moving into that application, it is going to give the particular output of that, the new output only. So like this, we can use these Databricks for our real-time projects and all. For when we are going to use in real-time production level and all, we are having multiple options, we are having multiple features and all. But as in free edition, it is a limited only. But for your experiments and all, for your R&D and all, you can easily carry out this Databricks community edition. No worries. Okay, so like this, you can create this all the options and all. So yeah, that's it from my end. If you have any doubts in Databricks community edition, else if you have any doubts in Databricks, please ask me the question. Because before we are going to do anything about this deep learning, artificial intelligence, machine learning and all, the data is very, very important. In initial only, I told that the data information, data understanding, how we are going to deal the data, how we are going to get the data. So this is very, 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 very important. Because without data, we could not do anything, right? Because we are going to train the models and all with the data only. So images only, videos only. So this is what. Yeah. Anybody having any questions?
Participants, any questions you can just ask with sir.
Many applications, many the platforms are available to explore your knowledge, especially for this the machine learning, generative, and then this GAN technologies and all. So in our current project also we are using this GAN only. So because I'm not able to show that how we are using and all, because that is a very confidential in my organization. So
Sir,
yes,
good evening, sir.
Very good evening,
Sir,
sir.
actually, good evening. So actually, we are depending on the online platforms for implementation of GAN and other generative AI related things. So suppose if you want to work with standalone computer and our desktop computer in the laboratories, which is the right platform to use it?
So the right platform in the sense, if you want to do any R languages and all, the PyCharm is also available, right? So that R language tools and R Studio and all is there, right? You can install it and then you can use it for the free edition.
Okay. So
Or else you can use this database. Yes, sir, please.
The same performance will be provided by using those PyTorch and
No. Because these are the on-premises, right? Absolutely, we could not expect the same performance from the cloud how we are getting.
Okay.
And then it is taking more time also, sir, because installation, again, you need to dig into that and then the process and all. But once you learn it, it is very good for us.
Okay. Okay, sir. Understood. Thank you. Thank you so much.
Yeah, welcome, sir.
So can you like give few more use cases, sir? Like you're working in IT now. So like any real-time use cases, if you would share with us, though, it will be helpful for us.
Okay, the real-time experience or else the few scenarios in my current project only. In my previous project, explain that the thing is I will share. I'm going to share with you, right? I think so. We guys know about of this Emirates flight, right? So what is the work I carried in that Emirates project? Okay, so that Emirates project architecture is like this. They're having the source data. The source data, the landing zone is the Azure Blob Storage. We know you guys know about of this Azure Blob Storage, right? So and then this Azure cloud technology also. In that project, we use this Azure Blob Storage. Azure Blob Storage is the landing zone for that input data or else the source data. That Azure Blob Storage having the source data. After that, what we are going to do is we are going to use this the Databricks Spark as an ETL tool and then for the transformation tool. And then we are getting the data from this Azure Blob Storage and then from the Azure Blob Storage to this Databricks environment. How we are going to get this data from this Azure blob storage to the Databricks environment? By using the mount technology or else mount feature in this Databricks. Once we get this data into this Databricks, and then as a developer or as a machine learning artificial intelligence engineers or as big data engineers, we did some transformation. The transformation in sense, as I explained you, right? This is a simple example I have shown you, the drop duplicates and all. Like that, the complicated scenarios, the complicated the tasks are there. In my project, I need to find out, let's take an example, I am a passenger. If I enter to that Bangalore airport, so instead of that booked the ticket, that Emirates company want to know about of that passenger, what are the things he is going to purchase in that airport. So that we can call it as the network and then host and then on premises. This on premises and in the sense the Bangalore airport, and then the another one is the international RLs outside of this Bangalore, and then what I told this the network in the sense complete this the combine of these two the airports. Like that, I need to segregate this data and then I need to give it to the customer. So means as a Girish, what are the things I purchased on the airport? These are the sum that because of to calculate the revenue or else to calculate how much the revenue is generated from the individual user, is an occasional user or else is a rarely user or else is a regular user or else he is going to order anything in the airport and all. Because you guys know about of this, once you purchase it anything, once again that in your mobile phones or else on a laptop, again and again it is pop-upping the same messages, right? It is in maybe Zomato, it may be anything, the food orders and all. Because of they are going to tempt you, and then the next time you must have to order that the whatever the things if you want it. So like this, they are getting the data, and then we are trained up the data into that the models of this machine learning and this and then artificial intelligence. So like this, once we transform the data, again we are going to we save the data into the Azure SQL. That Azure SQL, that is one of the data store also. We store the data. Then after that is machine learning team and then artificial intelligence team, or else the business intelligence team. The business intelligence team, they are using this Power BI to generate the business reports in the graphical representation. As a machine learning and then artificial intelligence data, already this is the trained data. Already it is the cleaned data. So no need to worry about this data and all. As a machine learning team, we get it the data, and then by using this TensorFlow technology, by using this machine learning, we tried into that model, and then we are whatever the predictive values, or else this customer is maybe is going to buy these products in future more. So therefore, the same product it is going to show it in your mobile phones or a desktop. So like this, this is the main project we carried out in my Emirates project. I think so. You guys understand, right? So like this, the organizations, they are increasing their revenues and all. You know already YouTube videos and all, right? So once you watch the same video, it is again and again the same the related videos only it is pop-upping in your screen. So like this. Yes, madam. I think so if you don't have any questions, that's it from my end.
Sir, how about the research opportunities, sir? Like research wise, can you just give some note for us?
As I told that the GAN technology, right? The GAN technology, I had shown that few examples, few applications only. And then I think in beginning, one of the person he asked, I think so Sunil or I don't know. He asked about the signal processing also, right? In that applications also, we can use this GAN technology. And then we can do our own research work, and then we can get it the whatever the desired output. We can apply the GAN technology into the different applications.
Okay, sir. Participants, any questions, so you can ask with sir.
Sir, can you hear me, sir?
Yes, madam.
Sir, could you please tell about the challenges that
Challenges, right?
when we are using GAN for yeah, and as well, kind of what kind of parameters we are supposed to tune so that the models can perform well when we are incorporating this GAN?
Yeah, I'll tell you. Just give me 1 minute. I will be back. The guest is coming. Okay, 1 minute. I will come.
I request the participants to post the feedback until the sir returns back. I post in the chat as well as I'm posting in the WhatsApp group as well.
Sorry, madam, I'm back. Hello.
Yes, sir.
Madam, you're
Yes,
able
sir.
to see my screen?
Yes,
No,
yes,
right?
sir. Yeah.
No, I'm asking you're able to my screen or else what?
Yes, sir, we can see.
Yes. So in real time, if I explain that, I think so you are not able to understand that. That is the reason. Just a minute. See, whatever the difficulties or challenges we can face it in that when we are using this GAN technology, that training of that instability also. So because as I told that this GAN involves the two competing models, right? That is what generators and then discriminator. So if one learns too quickly and then it is going to train the diverge, means that is what we can call it as a model collapse. Hello.
Yes, sir. Yes, sir.
Okay. Yeah, model collapse, and then we can use we can overcome this by using this the future matching also. And then another one, the challenges what I faced, the evaluation difficulty. So that is what, as I told, that supervised models we can expect that evolution, that exact output and all. But when we are using this unsupervised learning model, we could not expect that that explicit accuracy and all. So that is the reason we can use the different inspection, the scores, the technology or else algorithms and all. So like this, and then when we are using this GAN technology, this is the high computational cost. So as compared to the supervised technologies and all. So, but there is no solution for this. That is the reason we need to use only, instead of this all-purpose cluster, we can use this the job cluster purpose and all. So like this, we can get the solution for this.
Okay. Sir, thank you, sir. And one more thing. Sir, when we use this GAN, for example, if I have kind of 100 images I have, and of this 100 images, I have different classes, like consider 5 classes I have. So all these classes were imbalanced. Obviously, the purpose why I require for GAN might be it is imbalanced. So I need to balance it. So what is the minimal number of images required for GAN to perform well? Which means I'm asking, suppose if I give, even if will the GAN be providing the better results if I give only 6 images as an input?
No, madam. See, you are talking only in research, means for the research purpose only. But in real time, we are processing lakh crores of images and all.
Yeah, that's what I'm asking. That is what my requirement is actually. So kindly tell us what might be the minimal requirement for the better performance of the GAN, and what kind of images, or what kind of, how it is creating a new images, like in the perspective of the images.
Especially, we know, see, if we are going to deal only the less amount of the data and all, I think it is not going to give any the differences and all. But always, if in production environment and in real time environment and all, we are using the terabyte of data, petabyte of data and all. So minimal data, it's not like that minimal and all, madam. So we can use how much you want, you can use it. But in production environment, in real time scenarios and all, we are not using very less, because whatever the technology is, the big data or else artificial machine learning and all, absolutely it is not going to good for that small amount of the data. So only we are going to do it for the large amount of data only, right? So only we can consider the large amount of the data. But in my real time experience, we are on daily basis, we are going to process terabyte of the data, 10 terabyte of data, or 10 byte of data of images.
Okay, so fine. So how can we, for kind of the cases where I have less amount of images, could you please suggest any other technique that can be adopted for balancing the images?
See, balancing, see, in GAN also it is possible, madam. I'm not saying it is not possible, but for that good outcome and all, we must have to use the number of or thousands of images and all, we can use the GAN also, no worries. Because when we are using the less images or less amount of images, but we not came to know that that exact output, or else we are stuck on to only limited images only, right? So we could not explore more things. So we can use GAN only, no problem.
Okay, that's it. Won't it affect the output, sir? Suppose if I use on less images, will it have impact on the output?
No, it is not going to impact. No, it's not. No, yes. No, you are not. In the sense, we are not going to explore the different scenarios and all. That's in that context I'm telling. It is not going to do any lose and all nothing.
Okay, sir.
Sir, if our data set is unbalanced one, do we need to make it as balanced before using the GAN? Is
Absolutely,
it necessary?
madam.
Yeah.
That is absolutely, that is very needed. Without your balancing and all, and then how that the trained model it is going to understand. That is what we as a big data developer, as a data engineer, our role is like that only. We need to cleanse up the data. We need to make it into proper way to the trained model.
Okay. So we can use random.
Madam, your voice is breaking. Ashita, hello. Ashita, madam, can you repeat your question?
Sir, we can use random oversampling also there, no, sir, for that balancing.
Yeah, random values in the sense that images and all. So in that, when you're talking about the unstructured data and all, absolutely you are correct. That imbalanced data only we are going to use it. But before that, already we have stored that real-time data only, right? That whatever that exact images and all. Like that also we can. So in that context, you are asking, okay, yeah, we can use that unbalanced the data and all. Yes, we can use it.
Oh, sir. Like we are hearing about this quantum computing only from few sessions. So like, is there any correlation between GAN and quantum computing, sir?
Yeah, madam, it is correlating only the quantum part, the quantum things and all. But here I did not cover more things because there is no much to know about of this quantum and all. So only the less thing only, but it is a correlative, madam, both this GAN and that quantum.
Okay. Like we were hearing, like in quantum, it is all about quantum mechanics, whereas GAN thought is full of machine learning. So can you
Absolutely.
just can you give any one examples related to this, anything?
The quantum computing in the sense, as we know that.
It is also fine. How would be the future of this also would be fine.
In the sense, instead of this GAN, how we are going to use this quantum and all?
Yeah, quantum GAN with quantum, how it can.
Oh, in real time, I did not work on that much on the quantum, the computing and all. It is irrelevant only. Maybe I will get to know, madam. I will get to know later part in feedback form and all.
Thank you, sir. Thank you so much, sir. Participants, if any query, please do ask with sir.
Participants, if you have any queries, please ask.
So, are there any simple hands-on practical examples that someone new to GANs can actually start implementing?
Yeah,
Any
madam, it is
references?
there, but it is taking more time to explain. I think so. I need half of the day to show you that the hands-on session on that GAN.
Yeah, but at least something where we can ourselves go through it and try implementing it on our own. Is there something like that that we can refer to from the available resources?
That is what I'm. You can Google it. The many papers are available, and then for the framework and all, for the platform and all, you can use this Databricks only.
Okay.
Yeah, you can use easily because of there are two sections as I explained to you, right? That the data engineer and then automation machine learning part is there. You can
Machine
utilize
learning,
automation
yeah.
and machine learning part. You can explore
Okay.
more.
Okay. Thank you, sir.
Sir, how about ETL and Databricks, sir? Like any differentiation? ETL
No,
tool
madam.
and data.
ETL is a part of this Databricks. There is no difference like that. Let's take an example. Girish having high nose and then so hands and all, right? So like that, it is different features having this Databricks. Do not depend on that on premises or any standalone applications and all. It is having these all the features.
Excuse me, sir. This is Dr. Persis. Can you hear me?
Yes, madam, I can hear you.
Sir, it is a very basic question from my side. Sir, you were talking about some generator and discriminator, right? So what will happen if the discriminator gets too strong and also the generator gets too strong? What will happen?
Too strong in the sense I did not get
See,
your
if it
question.
works in a very perfect way means what will happen is my question. If the discriminator works very perfectly, then it can easily reject the fake samples, right? Then if the generator works too strong, that is, it works perfectly, then it failed to learn something else, right?
Yeah, that is what I think. So one of the, I think so maybe Prabhadevi, she asked about the challenges and all,
So
right?
what happened then? If you are, if you want to implement this and if you want to use this one in our research, it will lead some infinite thing, right?
No, that is what if it is as your understanding, absolutely the result is no convergence between that discriminator and then this generator. That poor quality of the samples we can get it. That is not, we are not get it that expected high quality of the samples and all. Only poor quality of the samples we can expect it.
Okay, okay. Then if you are implementing it in a real time scenario, is it possible to get the perfect result?
Yeah, madam, absolutely. Yes, absolutely. That is a
Okay.
reason. You see, you know, in our job and all, if you did not get it until and then they will not leave us. We must have to get it the proper output only to them.
Okay, okay.
Customer requirement.
But you are telling that still there is some challenges over here because we are all researchers. So we want to know, is there any a place to do research in this area? So
absolutely. See, you can use this future matching also. So future matching, and then you can use apply that gradient penalty also. So like this, you can do your research and all.
Okay, but implementation is costly. What you are telling is
absolutely, implementation is costly. Yes. High cost. That is what one of the challenge, or else I can say as compared to other things.
Didn't hear you.
Can you hear me, madam?
Yes, now, sir.
Yeah.
So it is too costly to implement.
Yeah, absolutely. See, as compared to in production environment, I'm talking. As a research and all, I think so it is not too expensive. And when you're going to real time, so let's take an example in my organization, when you're dealing and all, absolutely it is a terabyte of data, petabyte of data and all, the computing resource, everything is cost only, right? So in that context, I'm telling it is too expensive. If you want to carry your research and all, I think so it is not going to affect your cost and all.
Okay, thank you so much.
Welcome.
So if no questions, though, we can wind it up. Thank you so much, sir. Participants, if any questions, please do. You can ask with sir, since he's there with us.
Yes. So I think so. They don't have any questions, Shweta madam. I think so.
Is anybody, if anything, please make use of this platform. So thank you so much, sir. Like we were able to explore on GAN and especially on Databricks. So definitely the participants will try out for that that free edition you told, na? So definitely they'll make use of it. So still any
Thank you so
questions?
much.
Yeah, if
Yes, sir.
anything, you can just make use of this platform.
So before that, I would like to say thanks to this MS Ramaya Institute, the management and all, and then you and then Prabha Devi Madam and all you communicated, and then thanks for this audience throughout this session will last from 1.5 20 minutes, 1 hour 25 minutes. You are listening my words and all. So and then whatever the other things I am doing in my real time, just I explained that according to that. So if you want to know anything about, just get it to me through that email ID and all. Already I provided to that the coordinators. So thank you so much for listening my words and all with patience.
Thank you so much, sir. Definitely we will be sharing the material, whatever you are going to provide. And definitely we'll share the link of you also if in future, if they want to get in touch with you, definitely they can.
Sure.
And
No
thanks
worries.
once again, sir, like for providing a schedule of you. Thank you so much. And
Most
definitely
welcome.
I hope like all of them are benefited in some way.
Yeah, please, I want to know the feedback, how they are utilized this session, and then what are the things they understood it, it is useful or what. So yeah, madam.
Surely, sir, we are going to collect it and we'll be circulating to you. Oh, thank you, sir. The participants, so they can fill the feedback form, which has been circulated in WhatsApp group. So please do fill it up. We will be starting with the very next session. Thank you so much, Dr. Girish, sir. Thank you once again.
Thank you, madam. Thank you so much, Shweta, madam. Thank you all.
Thank you so much.
Thank you, sir.
Thank you. Thank you.
Thank you so much, sir.
Thank you. Thank you. Thank you.
Yeah, thank you. Thank you.
Shall I leave from this meeting, or else you guys are
Yes,
going to end
sir.
up?
Yes. Yes, sir. You can leave, sir.
Thank you, madam.
Yes.
Thank you so much. Thank you. Have a great evening. Thank you. Bye bye.
Thank you, sir. Bye. Vincent, sir.